You have probably seen videos on YouTube where people say you can replace Claude or Claude Code with a local model. For some jobs, that is true. Smaller local models can write useful code, search your files, summarize documents, and handle repetitive work privately. But what if you want the kind of open model people are now comparing with Claude Fable 5? Fable 5 sits at the top of the intelligence charts today. So what kind of computer would you actually need to run something in that class locally? A question on X put it very simply. What computer do I need to run the latest Kimi K-3? How many Nvidia GPUs or how many Mac Studios? I also found a Reddit thread asking what it would take to run a Fable class model locally for 100 people. The answers were all over the place. One person guessed 4 H100 GPUs. Another said 8 B200. Someone else just said you would need a rack. So that is what we cover in this video. We will use Kimi K-3 as a public example, do the basic memory math, and answer 3 questions. Can a Mac Studio run it? Can one Nvidia server run it? And what changes when 100 people use it at once? The short answer is that this is much closer to a data center project than a desktop project. Let me show you why. I want to be upfront about one thing. We cannot do this calculation with the real Claude Fable 5 because Anthropic does not publish the parameter count, the full architecture, or the model weights. Anyone giving you an exact GPU count for Fable 5 is just guessing. Kimi K-3 gives us something real to calculate. Kimi says K3 has 2.8 trillion parameters and a 1 million token context window. Its launch materials compare it directly with Fable 5 across coding and agent benchmarks. That does not make Kimi identical to Fable, though. Kimi's own blog says K3 still trails the strongest proprietary models overall. And a benchmark score is not the same as doing your actual work well. One person in that Reddit thread saw a claim that an open model beat Fable on some benchmarks. They replied, "This is a sign to retire the said benchmarks." That is a fair warning. So I am not calling Kimi K3 a Fable 5 replacement. I am using it because it is a frontier scale model with a published size. Kimi says the full weights land by July 27th, 2026. Until those files and the serving software are public, what we can calculate is the memory floor. So let us run the math. Kimi K3 is a mixture of experts model. It has 896 experts, but only 16 are active for each token. That reduces the amount of computation needed for each answer. It does not make the other experts disappear. For fast serving, all of those experts still need to be available across the system, because the model may pick different experts for the very next token. Kimi says the weights use a 4-bit format called MXFFP4. 4 bits is half a byte per parameter. So the simple math is 2.8 trillion parameters times half a byte. That gives you about 1.4 terabytes, just for the raw weights. And that number does not include the extra data the 4-bit format carries, the inference software, active conversations, or any safety margin. It is the floor, not the real total. Now we can answer the laptop question. The largest Mac Studio can be configured with 512 gigabytes of unified memory. That is definitely not enough. Even if someone eventually ships a 2-bit version, the raw weights would still need about 700 gigabytes, and the Mac Studio tops out at 512. A Mac Studio can run very useful local models. It cannot hold the full Kimi K-3 in memory. What about the comment saying 4H100? 4H100 GPUs with 80 gigabytes each give you 320 gigabytes. That is even less memory than the largest Mac Studio. So 4H100S are not enough either. Now we get to the first serious server. A DGX B200, the Blackwell box, has 8 B200 GPUs and 1.44 terabytes of total GPU memory. Kimi K-3 needs about 1.4 terabytes for the simple 4-bit estimate. On paper, that looks almost perfect. In practice, it leaves only about 40 gigabytes. The 4-bit format, the runtime memory, the context, and the serving software all need space too. So an 8 B200 server reaches the arithmetic floor. I would not call it a practical, fast setup. The DGX B300 is more believable. It has 8 B300 GPUs and about 2.3 terabytes of GPU memory. That leaves roughly 900 gigabytes beyond the raw 4-bit weights. One B300 server may be able to load Kimi K-3 with useful headroom. We still need the real weights and real benchmarks before anyone claims how fast it will be. But Kimi's own launch blog points to a much larger setup. For efficient inference, Kimi recommends a super node with 64 or more accelerators. Kimi is not saying 64 accelerators are the minimum to start the model. But if the company that built K3 recommends 64 for efficient inference, one server is not the full answer. Those are 8 GPU servers. So we are talking about at least 8 servers. That is not a computer under your desk. That is a data center deployment. So the Reddit thread asked about 100 users, but one comment corrected the question, and it is exactly the right correction. 100 users is not the same as 100 parallel requests. Suppose 100 employees each send one request every 10 minutes, and each answer keeps the system busy for 30 seconds. If the requests arrive evenly, the average is about 5 active requests, not 100. But AI agents change that fast. One developer might have several coding jobs running at once, and the context window matters too. Kimi K-3 supports up to 1 million tokens in one request, though that is a maximum, not a normal target. Longer prompts and more active requests need more runtime memory. That is why hardware for 100 users has no single answer. You have to know how many requests are active at your busiest moment, how long the prompts are, and how fast answers need to come back. The physical setup is easy to underestimate. Nvidia lists one DGX B300 at 14.5 kilowatts. Run 8 of them, and the published figures hit about 116 kilowatts before cooling. One person in that thread said their company runs several dozen B200, and turning them on sounded like sitting behind an Airbus A380. Not a benchmark, but it makes the scale clear. You need high-speed networking, storage, power, cooling, monitoring, and people who can actually operate the thing. And the rental math is large too. Multiply today's public 8 B200 node prices by 8 nodes, and the compute alone lands somewhere around $313,000 to $577,000 per month. That is rough scale math. Not a quote, but it tells you the order of magnitude. The best answer in that thread came from someone who ran an LLM service for thousands of users. They said a model that is good enough and that you can scale beats a super model that only serves a couple of people. That is the practical answer for most companies. A smaller private model handles document search, extraction, classification, or routine coding. The hardest task still goes to Claude or GPT. That is the pattern I keep finding from people who already spent thousands on local hardware. It was almost never fully local. Local models for private or repetitive work, cloud models for the hardest tasks. And the simplest buying advice in the thread: rent the hardware for a couple of weeks and see whether a few real users like the results. That test tells you more than any benchmark chart. Whether the model can do your work, whether it is fast enough, and how much effort it takes to keep running. So, what would it cost to run Claude Fable 5 locally? Honestly, you cannot, because the weights do not exist outside Anthropic. But using Kimi K-3 as a frontier scale stand-in, the answer is clear. A single Mac Studio is not enough. 4 H100 are not enough. An 8 GPU B200 server reaches the raw weight requirement but leaves almost no room for the rest of the system. And for efficient inference, Kimi itself recommends 64 or more accelerators, which is 8 servers, not 1. For 100 employees, the final number depends on how many requests are truly active at once, not the headcount. Local AI is real. Private AI is real. But private frontier AI at this scale is a data center project, not a laptop feature. More GPUs can make a model faster. They cannot make the wrong model equal to Claude Fable 5.